This is going to blow your mind. There are over 2 trillion galaxies in the observable universe. Each of these galaxies is separated by vast cosmic distances, often millions of light-years apart. The sheer number and scale of these galaxies challenge our understanding of the cosmos. We live on a planet, Earth, a beautiful blue marble teeming with life, floating in the vastness of space. From the vantage point of the International Space Station, we can see our planet in all its glory, rotating gracefully against the backdrop of the infinite cosmos. Earth orbits a star, the Sun, which is a massive glowing ball of hot plasma. The Sun provides the energy that sustains life on our planet, and its solar flares and sunspots are a constant reminder of its dynamic nature. Our Sun is just one star among hundreds of billions in the Milky Way galaxy. This vast collection of stars, gas, and dust forms a magnificent spiral structure that stretches across the night sky, a testament to the grandeur of our galactic home. But here's the mind-blowing part. The Milky Way is just one of trillions of galaxies in the observable universe. Each of these galaxies contains its own multitude of stars, planets, and possibly even life forms, making the universe a place of endless possibilities. Yes, you read that right, trillions. The sheer number of galaxies boggles the mind and challenges our understanding of the cosmos. Each galaxy, with its own unique structure and history, adds to the richness and diversity of the universe. Our cosmic address is far grander than most of us ever imagine. We reside in the Milky Way galaxy, within the Orion Arm, on a small planet orbiting an average star. This perspective helps us appreciate the vastness of the universe and our place within it. It's a humbling reminder of our place in the grand scheme of things. When we consider the immense scale of the universe, our daily concerns seem to shrink in comparison. We are but a tiny speck of life on a tiny planet, yet we have the capacity to explore and understand the cosmos. We are but a tiny speck of life on a tiny planet orbiting an average star in a vast and ancient universe. This realization can be both humbling and inspiring, as it underscores the preciousness of life and the importance of our stewardship of Earth. As we delve deeper into the cosmos, we encounter distances and scales that are hard to fathom. Space probes and telescopes extend our reach, allowing us to explore regions of space that were once beyond our imagination. Each new discovery adds to our understanding of the universe and our place within it, but the journey is well worth it, for it reveals the astonishing beauty and grandeur of the universe we inhabit. From the intricate patterns of nebulae to the majestic dance of galaxies, the cosmos is a source of endless wonder and inspiration. As we continue to explore, we deepen our connection to the universe and our appreciation for the delicate balance that sustains life on Earth. To grasp the sheer scale of the universe, let's consider a few mind-boggling numbers. Light, the fastest thing in the universe, travels at approximately 186,282 miles per second. That's incredibly fast. Even at that speed, it takes light about 8 minutes to reach us from the sun. Now imagine the time it takes light to travel across the vast expanse between galaxies. It's measured in millions of years. When we look at distant galaxies, we are seeing them as they were millions of years ago. This is because the light from those galaxies has taken millions of years to reach us. The universe contains an estimated 2 trillion galaxies, each with billions of stars. The distances between these galaxies are so vast that they are measured in millions of light years. Understanding these immense distances helps us appreciate the true scale of the cosmos. So how many galaxies are there in the universe? Based on observations from powerful telescopes like the Hubble Space Telescope, astronomers estimate that there are at least 2 trillion galaxies in the observable universe. This number is constantly being refined as our telescopes become more powerful and our understanding of the universe deepens. It's important to note that we are talking about the observable universe. The observable universe is the portion of the universe that we can currently observe from Earth. There may be many more galaxies beyond what we can see, hidden from our view by the vast distances and the finite speed of light. The distances between these galaxies are mind-boggling, often measured in millions or even billions of light-years. This means that the light we see from some galaxies has traveled for billions of years to reach us. As the universe expands, these distances continue to grow, making the cosmos an ever-changing and dynamic place. Estimating the number of galaxies and the distances between them is no easy feat. Astronomers use a variety of methods, combining observations with sophisticated mathematical models. One common approach is to study a small, representative portion of the sky in great detail. By counting the galaxies in this small region and extrapolating to the entire sky, astronomers can estimate the total number of galaxies in the observable universe. Another method involves analyzing the gravitational lensing effects of massive galaxy clusters. Gravitational lensing occurs when the gravity of a massive object, such as a galaxy cluster, bends the light from more distant objects behind it. By studying these lensing effects, astronomers can infer the presence of unseen galaxies and refine their estimates. To measure distances, astronomers often rely on the redshift of galaxies, which indicates how fast they are moving away from us due to the expansion of the universe. By applying Hubble's law, which relates redshift to distance, they can estimate how far away these galaxies are, providing a clearer picture of the vastness of the cosmos. Section 5. Hubble Deep Field, a glimpse into the abyss. One of the most remarkable astronomical images ever captured is the Hubble Deep Field. This image has captivated scientists and the public alike, offering a window into the distant past of our universe. In 1995, the Hubble Space Telescope was pointed at a seemingly empty patch of sky for 10 consecutive days, collecting faint light from the most distant objects ever observed. This ambitious project was a gamble, as no one knew what, if anything, would be found in this tiny, dark corner of the cosmos. The resulting image, the Hubble Deep Field, revealed thousands of galaxies, each a sprawling collection of stars, gas, and dust. These galaxies varied in shape, size, and color, painting a complex and dynamic picture of the universe. Some of these galaxies are so distant that their light had been traveling for billions of years before reaching us. This means we are seeing them as they were billions of years ago, providing a glimpse into the early stages of the universe. The Hubble Deep Field provided compelling evidence that the universe is teeming with galaxies, stretching back to the dawn of time. It showed that even the darkest, most unassuming regions of the sky are filled with countless galaxies, each with its own unique story. It was a profound moment in astronomy, demonstrating the incredible power of telescopes to peer into the depths of the cosmos and uncover its hidden treasures. The Hubble Deep Field not only expanded our understanding of the universe, but also inspired future generations of astronomers to continue exploring the vast, uncharted territories of space. This image stands as a testament to human curiosity and the relentless pursuit of knowledge. It reminds us that the universe is far more vast and wondrous than we can ever imagine, and that there is still so much more to discover. Section 6. Galactic distances, mind-boggling gaps in space. The distances between galaxies are truly mind-boggling. The average distance between galaxies is estimated to be millions of light years. To put that into perspective, 1 light year is the distance that light travels in 1 year, which is about 5.88 trillion miles. Even if we could travel at the speed of light, it would take us millions of years to reach even the nearest galaxies. There are billions of galaxies in the observable universe, each separated by these vast distances. The universe is not a static, unchanging entity. It is a dynamic and ever-evolving realm, with galaxies moving and interacting over vast stretches of time. Section 7. Analogies for understanding, from grains of sand to Earth's orbit. To make these cosmic distances more relatable, let's use a few analogies. The vastness of space can be difficult to comprehend, but by breaking it down into more familiar terms, we can start to grasp the enormity of the universe. Imagine holding a grain of sand at arm's length. This tiny speck, almost insignificant in size, can help us understand the scale of our galaxy. That tiny grain of sand represents our Milky Way galaxy. The Milky Way is a vast collection of stars, planets, and other celestial bodies, all bound together by gravity. Now, imagine another grain of sand about 2 feet away. This small distance in our analogy represents a much larger distance in space. That second grain of sand represents the Andromeda Galaxy, our nearest major galactic neighbor. The Andromeda Galaxy is similar in size and structure to the Milky Way. The distance between these 2 grains of sand, relative to their size, is roughly equivalent to the distance between the Milky Way and Andromeda. This analogy helps us visualize the vast emptiness of space between galaxies. Another analogy involves Earth's orbit around the Sun. Our solar system is just a tiny part of the Milky Way galaxy, But even within our solar system, distances can be mind-boggling. Imagine shrinking the sun down to the size of a basketball. This helps us scale down the vast distances in our solar system to something more manageable. On this scale, Earth would be about the size of a pinhead, orbiting the basketball-sized sun at a distance of about 25 feet. This analogy helps us understand the relative sizes and distances within our solar system. Now, imagine placing another basketball about 6 miles away. This represents the distance to the nearest star system, Proxima Centauri, from our Sun. That's roughly the scaled-down distance to the nearest star system to our own. These analogies help us grasp the immense scales involved in our universe, from the tiny grains of sand representing galaxies to the basketballs symbolizing stars. By using familiar objects and distances, we can better appreciate the vastness of space and our place within it. Section 8. Notable neighbors, Andromeda, Triangulum, and beyond. While most galaxies are incredibly distant, there are a few notable galaxies relatively close to our own. The Andromeda Galaxy, also known as M31, is the closest major galaxy to the Milky Way, located about 2.5 million light-years away. It's a spiral galaxy, similar in size and shape to our own, and is on a collision course with the Milky Way. Don't worry, though, the collision won't happen for another 4 billion years or so. The Triangulum Galaxy, also known as M33, is another close neighbor, located about 3 million light-years away. Both Andromeda and Triangulum are part of the Local Group, a collection of over 50 galaxies bound together by gravity. These galaxies, though relatively close in cosmic terms, are separated by vast distances, highlighting the immense scale of our universe.